Hello tout le monde. Moi c'est Nicolás. Par contre, je vais faire la présentation en anglais. J'espère que ça dérange personne. So, the name of the talk originally was Mutex, Atomics, and Beyond. There's a reason for that. Today I'll cover the Mutex part. You would say, why we're talking about Mutex? That sounds like something that we probably saw at school. I don't know if you, but I learned the C language at school, and well, that was kind of the things that you had to learn. And I want, I'm pretty sure that you all know Daniel Steinberg. He always, like I says, something at the beginning of his talks. He says the code is not that important, the ideas are. So I put some code there, but try to follow me along, okay? So, okay, let's say that, okay, on your application you have some sort of course, some sort of a state that you want to keep in memory because you want to do stuff regarding that state. Maybe you're observing it, any reason. And simplest thing to do, you open a playground maybe, you have a simple package, whatever it is, on your, could be your main function at the beginning, and you create a variable. Could be something simple, a Boolean variable. If you have activated the Shift6 flag on your Exo projects, as I suppose you all already did, you will get something like that. Reason is because this is just a floating variable somewhere in your, it isn't enclosed by anything. So kind of like the simplest thing to do is you enclose it, you put it inside the type. So simplest thing, okay, let's put it inside a class. That should do it. The compiler error is gone, so great. But if you are compiling your code with Shift6, you know that there's a problem. That already is not thread safe because, I mean, you could have different colors that could have a reference to this class. Could be a shared instance, for example, as it is a reference type. And technically, different colors could access, could mutate this, so it's not really thread safe because you don't know at compile time what asynchronous context is accessing the variable, so it gets a bit complicated. So there you could say, okay, this maybe the simplest thing to do is I could put some sort of internal dispatch queue. That's what a lot of code already does to protect internal state. Well, that was kind of like a trick to do like before actors. So you could say, okay, that normally works. You can now provide the read and write access to this variable from the outside, but you're safe because now it's protected by a serial dispatch queue. But there's, let's say, like a less evident cost that there's, of course, you are creating a dispatch queue, so dispatch queue is going to kind of like manipulate and, in theory, a new thread is going to deal with that. So you have like this little overhead that is not that evident. But today also we have safe concurrency, so why should we still do that? I mean, if you're running Shift6, you know that, okay, you have this class, but if you want to, for example, move an instance of this class between different async contexts, there's an issue because the class is not sendable. So also quickest thing to do is you do that. This is very beautiful. You put just there uncheck sendable, and you kind of like you say, okay, YOLO, I'm kind of supposing that wherever is inside, I'm guaranteeing that it's safe to pass across different async contexts. And then the Shift6 compiler is happy again, because all your legacy code that you have to migrate, you just put a beautiful and check sendable there, and things compile very good. Then you could say, okay, but Shift concurrency was released in 2021. It's been 4 years already. And there are solutions that we can use as, for example, actors. It's quite easy. You get, I mean, it's kind of got the same structure that the class we had before, but the dispatch queue is not, let's say, visible, while the actor, there's an internal executor that deals with serialization, but that's not obvious for the developer, maybe at a first glance. But you could say, okay, I'm using an actor, so I'm getting the kind of this serialization, serialized access to the variable. So callers could access, mutate, write over this internal state. It's okay, it's thread safe, and because it's an actor, you get sendability by default, so that's kind of cool. But the thing is that there you are kind of like enforcing that, protecting now your internal state. You're kind of like putting this layer in between that you have to be on Swift concurrency async world kind of to deal with this with your kind of like your type there. And maybe that's something that you don't necessarily want to do. Maybe you just want to do like a very simple thing. Maybe you want to change some state based on your pressing, could be a Swift UI button or a UI kit button. Probably the components are going to trigger some sort of maybe like a escaping closure or so, but they are not giving you kind of like an async context that you could easily plug with this implementation. So there things get a bit ugly. Of course, you could say, if that's the case, if I'm kind of manipulating this code because of UI events, well, the execution will inherit the main actor, so it's kind of safe to do so. There are some, I think there are some trade-offs. There could be a nice thing, could be not, whatever. So the thing is that why do I get interested into this subject is because over the last few months I was kind of working with a client. The project was to kind of to rebuild synchronization SDK. This is it was very old code. It was mostly there's a Objective-C part. Swift it relied a lot on Grand Central Dispatch, so dispatch queues everywhere. There was even promise kit there, and the idea was to take the time to migrate this to, of course, Swift concurrency. And the thing is that dealing with internal state for me was, if I'm using Swift concurrency, I think the easiest thing is using actors. But sometimes I could use a dispatch queue because it's simpler. And then, but I wasn't kind of like really happy with the results because there's this, as I was saying, using actors, there's this hidden cost regarding an extra overhead that's not really visible at a glance. It's like when using macros, kind of like the same thing. So I started looking kind of like let's say legacy solutions and see what could we build from there. So, for example, if you go very back, go back into time when the dinosaurs exist, you had NSLOC. NSLOC is something that it looks like a C-level code, would say so. It works, it's safe, it's battle tested, it has worked, I don't know for how long, probably at least 20 years. You could do an implementation like that. You could mark your class as uncheck sendable. All good, that would work. But you could say that, but this is like you already have the NS prefix. It's old code. But I mean, if you go with a Swift concurrency solution, one of the cool things is that you get this compile time safety that your racing code should do whatever you want to do. And here, in fact, just taking a look at, for example, simple articles talking about why should we use NSLOC. People were just saying, in fact, there are more reasons to avoid using it. it's very easy to mess up things. As you can see there, there are some warnings that you should take care about. On the side, you have NSLock, and there's other lock that's called OS unfair lock. Maybe you have deal with migrating all the legacy Objective-C code. Maybe you have seen that somewhere. And the thing is that I didn't see it directly, but I saw this OS allocated unfair lock, and I didn't know about this, so I took a look at the documentation. I saw that you can see above important. If you have existing Swift code that uses OS unfair lock, change it to use the OS great. But you have this iOS 16 say requirement, so things got a bit complicated there. And again, okay, you would say it's like some sort of like a wrapper, Swift-friendly version of the lock. Great. If you take a look at how an implementation could look like, is something like that. It's quite nice because now, for example, as a difference with the NSLock, for example, I show you here that you have to manually say, okay, I want to lock a thread. I do an operation, and then I have to I can't forget to unlock that, or could generate a deadlock. Here it's more nice. It's nicer because when the available API with this lock is that it just gives you let's say a closure, and there you could do whatever you want, and no need to remember to unlock your lock. So great. Doing some extra research, I found this information. OS allocated unfair lock is currently the fastest lock in iOS, and then I found this. So it's quite nice. So you have, okay, on the y-axis you have time, on the x-axis you have the number of operations. Good. So you have the time passed, the number of operations, and you have this comparative saying, okay, on one side we're comparing the unfair lock, which could be a serial dispatch queue, and there's some overhead. There's a very interesting overhead, and here the same. You're comparing NSLock with unfair lock, and again the same. And from what I saw, this was running a very trivial piece of code. So you just kind of got the just the fact of kind of looking and unlocking the look, it creates enough overhead to run the benchmark. So that was kind of interesting because I thought that having a class with a dispatch queue inside kind of got to protect my internal state and put an unchecked sendable there was a good idea. Maybe it is, but it wasn't as performant as I thought. So the thing is that, okay, we have these solutions. We talk about that kind of the best idea was to go using an actor, that you have this low level and all the APIs that provide some locking mechanisms that you can use on synchronous contexts, but if today we are, notably with latest release of Swift, is 6.1, you have like so many updates regarding a more stricter concurrency. Like, why do we have to rely on some legacy types that come also from a C, Objective-C era? With Swift concurrency, like, there isn't something better. And there, if we go back to the last WWDC, for those who saw the video, what's new in Swift, well, if you watch it until the end, the thing is that over the last 2 minutes, it is announced, okay, we have a new module, it's called Synchronization, and there's a Mutex type, there's Atomics. Right, cool. And she does a simple demo, all great. I noticed that there was also a Swift evolution regarding this that I have no idea about, so I took a look. It's quite interesting if you want to see it. But then I thought we didn't have already an implementation for that. I took a look at over the internet and I found that, in fact, the Swift Atomics package was released during COVID times. And then I thought, why are we announcing something new regarding this if we already have a package there? But taking a look at the Swift Atomics package, it was kind of abandoned, not much changes over, I think, at least a year and a half. And there was somebody that created this pull request, creating a nice addition. It was a quite complex because at the beginning I didn't understand what was like introduce a non-copyable something. I didn't understand what that was. The PR is several thousands of lines, so and just to get this response saying, okay, this implementation looks great, but we are doing something different. And funny thing is that September 2023 is kind of at the same time that we're doing Swift testing as an open source package, but this one wasn't. If you take a look, okay, they talk about a non-copyable type, September 2023, as you said, Antoine. In September 2023, Swift.9 was released, and if you scroll down over the changelog, there was this section talking about non-copyable types and ownership. I would say that I didn't look at that much. It wasn't the subject that interests me the most. And the things that you already start to see, I mean, there's a kind of like some sort of trend today also in the community, like people complaining that, okay, in fact, since Swift 6, we have tons of new keywords that sound very complicated. We have, as you can see, like you have consuming, borrowing, you have sending. The language is starting to get a bit complicated. So, okay, so this new module / framework was announced, synchronization. So, okay, what's the new thing? Why it was announced? And also why it was announced during 2 minutes. So that means that it's not that really maybe interesting. Key points, okay, a new low-level primitives. You have Mutex and Atomics. Mutex is the one that interests me today. One thing, a requirement, I was still not sure why, but it requires iOS 18, so that may be a problem for those of you that are probably not working on a greenfield project as that. And its usage requires, I'd say, the previous understanding on some new information as keywords. If you take a look at the, say like the new mutex type definition, you say, okay, it says mutex is generic over a value where value must be copyable, but there's a, I don't know how you call that character before. So I had to take a look, and I learned that if you do that, it's called a negative constraint. That is in fact all the opposite. Instead of saying, okay, my type now is going to conform to some protocol, it's the opposite. You're going to strip the type of that capability. And that's, and I found that was kind of weird. And then there was this whole, since Swift 5.9, there's all this information available saying, okay, there are non-copyable types in Swift. They exist for a reason. And I couldn't understand why. And the thing is that if you maybe work before or have some knowledge on, let's say on C++, there's these semantics that's called move-only semantics. I'm not going to go into details on that, but there are two capabilities that are related to non-copyable types that I like to show you is that I told you that there were two new keywords. Sorry, there. So you have consuming and borrowing. So what's that, and why are we annotating our values in uncopyable? The thing is that, as you can see, okay, I think that I missed. Okay, it's basically the mutex is going to be okay, generic over a value, but this value, as it is non-copyable, inside the context of the locking, there are some, let's say, some guarantees there by using those keywords that whatever state you're exposing inside that lock cannot be modified on the outside. For example, there I think I could show you. For example, you have this. You could have a value type. You put this non-copyable, and you have these two new keywords, consuming and borrowing. So what does that do? Is that it's kind of like it allows you to manipulate a value type instance in a very weird way, saying that you can no longer copy this value, but you can, for example, pass it over a different reference. Only if you kind of lose the original reference or the ownership on this value. I think it's easier to explain with with some code. Let's say that, okay, you have an instance of this value type. You would put there whatever you want, and you have this function. I think I'll try first with this one. It says consumes, right? You get an instance of this, and you're saying, okay, when I call this function, I'm going to receive an instance of this value. In fact, the instance that I just created. But as this is named as consuming, what is going to happen is that the ownership of this instance is going to be moved to wherever is the callee or this new context that is here. And this reference to that instance is going to be invalidated. For example, if you do this, you'll get an interesting compiler error that is not actually the same. For example, if you call this. And that's a difference, saying that if I give pass as a parameter the instance of my initial value, here I could do a stop for, I could read values and so on. But once this function completes, I haven't lost the ownership of my instance. I can still do stuff. And you would say, like, okay, that sounds right, but what's the usage of that? One of the, let's say, one of the examples I found that was kind of easy to understand. Like, let's say that you have this type, you have a file handler wrapper, and you're pointing to a particular, let's say, part of a text file, could be. And let's say that, okay, on instance, you're going to call f open, so, okay, given a known path. And the thing is that, as it is a value type, in fact, nothing stops you from kind of copying that instance and doing stuff. And that will be weird because you have like some sort of like a duplicated reference of a type that's dealing with the same file that could create concurrency issues over the file. And that's where, for example, those are use cases where it could be interesting. Now, maybe one thing to kind of get to to understand also is that, like saying, okay, you're dealing with ownership, you're giving the, if you're consuming the instance, you're giving the instance to somebody else, then this someone else could give the instance to maybe it's another type. But that feels that as you can no longer copy the instance, it feels like some sort of like a singleton pattern. In fact, it is. And the funny thing is that when you, for example, when you want to invalidate the instance because you're giving ownership to something else, in fact, you can call a deinit, an initializer inside the value type. You can perform stuff. And this is something that kind of like doesn't make much sense in the sense of a value type. There are interesting things like this regarding uncopyable types. I think that we can discuss later if you see a more use case regarding this. I'm going to go back to the presentation. Now, if you go up to the, sorry, there was something I wanted to show you first. In fact, it was, if you take a look, for example, here we have our type definition goes above. You have your value type, non-copyable. And let's say here we have this grabbing type that kind of is encapsulating this implementation, so you have some sort of cache over this uncopyable resource. And the things that, because of the the signature of the mutex, now we are saying that the whatever instance you pass here is going to be unique to your mutex. For example, we are not allowed to do something like this. Let's say, I don't know, you have some sort of value. I'm going to, let's say, give an instance of this there. When you're saying, okay, it's you can pass an instance. I think there's something else called hello. Yeah, right. Sorry. And then you have this error. It's borrowed and cannot be consumed. Why is this? It's because the mutex doesn't allow us to provide copies of an already existing file. This is also to avoid, for example, inside the log closure, that whatever changes we do here cannot be interfered with the outside. For example, saying, okay, I want to change a value here, but maybe I would be dealing with some sort of a reference type that could be modified by something else. That's not possible. It only works with non-copyable types that have these new constraints, to say so. So from there, I saw like, okay, so cool. We have this new mutex stuff. Sounds great. Sounds a bit complex, but it sounds great. It looks kind of like easy to implement if you ignore the iOS 18 requirement. Also, going over the internet, I found this, and this looked quite interesting because I thought, okay, I already know that actors work. We have the OS allocated log, the fastest one that I was talking about, and you have this new mutex. So, what's the criteria? I mean, to choose one or the other. And I found this benchmark. So in parallel trivial tasks, the tasks are only like printing a string or something like that. And you can see that, of course, on a scale over the millions, actors are a bit slower, just a bit slower. It depends on probably on your needs, on your product needs, if you're going with one thing or the other. One thing to kind of like to retain, to keep in mind, is that why is the mutex kind of like that? Why does it fall in between the actor and the lock? Is because, in fact, the implementation of the new mutex uses the OS allocated unfair lock behind. So we are it's kind of like we have both, the best of both worlds. You have the fastest lock available, while you have this new API of non-copyable types that kind of like it has less friction with, let's say, with modern Swift and, of course, Swift concurrency. Here you have let's say, like a small table to compare what's this kind of what you get with each solution. So we went over the terrible global variable that, well, it's not good at all. And you can kind of like trace and go down as the latest available API. That's the synchronization mutex. Of course, kind of just to add an information there, on this project that I was working on, sadly it's iOS 15 plus, so I had to rely a lot on actors, but I'm kind of like looking forward to migrate kind of like a part of the protected internal mutations that I have to manipulate to maybe some modern, faster solutions. One at a time is right. Oh, sorry, I forgot to do that. So there you have some interesting reads. In fact, I don't know if the subject is like the most intriguing or not. For me, it was mostly part of my curiosity and then falling down a rabbit hole of information that maybe I didn't need, but at least I was able to kind of to demystify what non-copyable type was. I didn't present myself for, I think I know most of you, but my name is Nicolás García. It's a Spanish name. I have worked in iOS since a while, and luckily when I arrived, it was after the how you call it? ARC. So for all of those of you who have to work with Objective-C before that time, I'm very sorry. I think you did. And there are some kind of some companies that I worked with in the past. So that's it. Thank you. Oui.
Question. En français ou...
Peu importe. En espagnol si tu veux.
Non, donc en français. J'ai du mal. Enfin, est-ce que vous avez tous des morceaux de code où vous avez besoin d'autant de performance?
Plus longtemps,
ouais.
J'utilisais déjà des locks et tout, parce qu'il y avait beaucoup de concurrency. Donc j'ai utilisé des locks et des mutex dans le code Objective-C.
Ah oui, oui.
C'était à ma script pour faire le dessin. Et pour tout computer et tout, en parallèle. J'ai déjà utilisé des locks.
Et est-ce que les acteurs auraient suffi pour, en termes de perf pour toi? Ou il t'aurait fallu quelque chose de plus puissant?
Les acteurs auraient peut-être suffi, mais c'était en Objective-C pour des API qui n'étaient disponibles qu'en Objective-C.
Yeah.
Donc finalement, c'est éliminé pas mal les acteurs, puis c'était prêt, c'était avant les acteurs. Oui, je pense qu'après.
Yeah. Mais après, tu as aussi la couche async au milieu.
Ouais,
parce que tu utilises un acteur. Donc,
parce que c'est toujours. Enfin, moi, je sais que les seules fois où j'ai utilisé des choses comme ça, c'était sur du serveur multijoueur, tu vois. Vraiment où j'ai eu besoin de faire des trucs comme ça. sinon, c'est vrai que dans mon code de tous les jours, j'ai rarement besoin de ça.
Oui, pour moi, ça dépend du nombre d'opérations que tu fais. Oui.
Et c'est pour ça que j'aimerais, si quelqu'un avait, je sais pas, mais il y a peut-être un domaine, je pense que, je sais pas, la proba ou.
Après, c'est aussi toutes les apps où l'intelligence est dans l'app, au lieu d'être dans le serveur, qui utilisent beaucoup, justement beaucoup d'applications en parallèle et du coup qui utilisent énormément ça. Là, je présume qu'il n'y a pas d'intelligence serveur.
Non.
Donc là, pour le moment, tu n'as pas encore mis ça dans un projet.
Non, c'était juste de la curiosité.
Ouais, c'est super.
Regarder.
Ouais.
Je pense que normalement, si tu travailles sur, comment ça s'appelle, Embedded Swift,
Ouais. Bah là, oui.
tu as des contraintes de mémoire, donc forcément, oui. Mais sinon, je ne cache pas que vu la contrainte de iOS 18, c'est un peu compliqué. Ouais, c'est un peu compliqué. Donc, ok, c'est cool, ok, j'ai trouvé cette comme benchmark.
Ouais.
Ok, tu as 10 millions d'opérations, ça te fait une différence de 2 secondes. Peut-être que si tu n'as pas de 10 millions d'opérations que tu fais dans ton smartphone, ça t'en fiche, tu utilises un acteur, c'est pas. Même en serial dispatch. Mais ça dépend. Il y a un truc aussi qui me fait beaucoup peur, c'est que vu comme continue l'évolution de Swift, qui devient de plus en plus stricte dans la gestion des codes concurrents, je me suis dit que peut-être que c'est pas une mauvaise chose que je commence à regarder aussi comme des choses un peu comme side effects, on dirait, qui se passent à côté. Aussi pour mettre. Ça fait partie comme de ta boîte utile.
Ouais, bien sûr, c'est intéressant de savoir. Après, j'espère que ça va pas être un prérequis de comprendre ça pour pouvoir faire du Swift, quoi, parce que la barrière à l'entrée, sinon, pour les débutants,
C'est mis pour les débutants.
bah ouais, parce que tu arrives, tu manges des mots-clés dans tous les sens et tout.
Peut-être, je sais pas, j'imagine, de se lever à l'école, si tu as l'occasion de jouer avec un Arduino, avec des embedded Swift. Mais après, il faut s'intéresser à Swift aussi. Mais sinon, oui, ça reste bien niche.
J'avais une question aussi sur plus l'implémentation. Pour Mutex, on a vu qu'il faut que la valeur associée elle soit non copiable, c'est ça qu'on pourrait dire en français. Et je me demandais si c'était, ce que ça amenait comme contrainte ça ensuite, quand tu rends une valeur non copiable, est-ce que du coup si tu veux l'utiliser ailleurs et tout, ça amène des contraintes ou je m'en rends pas compte.
En fait, c'est que ça. La contrainte serait que tu serais obligé à utiliser la sémantique de borrowing, consuming partout.
C'est ça.
Oui.
Si tu ne mets pas l'un des deux mots-clés, le compilateur te refuse le truc.
Oui. Et en fait, c'est là ce qui est intéressant parce que de plus en plus, tu as les compilateurs qui vont t'aider à que ton concurrent code soit carré. Tu vois, c'est pas la même chose que si tu utilises un NSLock. Si tu oublies ton unlock,
c'est plus tard que tu t'en rends compte.
Oui, oups.
L'intérêt de la copie, c'est quoi? C'est de pouvoir suivre a posteriori l'état de l'évolution d'une valeur, en fait. Qu'est-ce que ça va. En fait, c'est la gestion du state dans le temps qu'on va pouvoir suivre. Parce que quelque part, tu pourrais utiliser ça de façon un peu cachée, tu vois, qu'il y a une espèce de cycle syntaxique que tu vois pas.
Oui, ça saurais pas dire.
Je sais pas.
Ouais.
Parce que pour moi, c'est après, pourquoi pas utiliser après une classe.
Après, ce que j'ai vu, c'est que si tu as besoin de compléter une application avec un SDK avant iOS 15, je peux dire, le meilleur, c'est d'utiliser les OS Unfair Lock et de te faire toi-même une espèce de lock avec une classe ou peu importe.
Avec des macros, par exemple.
Peut-être que c'est possible. Donc, voilà. Voilà.
C'est vachement bien. Pouvoir séquencer l'ADN sur
Mm.
son iPhone.
Pour miner du Bitcoin.
Ouais,
Donc voilà, c'était les Demystified. Bon, c'est avec Antoine, les Swift 5.9. On est un peu en retard quand même.
bravo.